This is part 2 of a video that I made last month titled How I Would Learn Mechanical Engineering If I Could Start Over. In that video, which was 20 minutes long, I discussed two key aspects of mechanical engineering. First is the curriculum and the material you need to learn, and second is the job hunting process and the skills and expertise needed to secure your dream engineering job. Many of you commented you wanted me to make another video focusing on the courses I took and my own progression, experience, and mistakes made in university. So I did just exactly that to address all of your specific questions. I'll build upon the first video by sharing the precise course sequence I followed in university and how I will choose my courses differently and the order in which you should prioritize key topics. I'll also cover several things I wish I had or knew earlier during my journey as a mechanical engineering student. By the end of this video, you'll know exactly how to strategize your course selection, approach learning the massive amounts of material, and unlock your full potential in university. Many of you are probably aware that YouTube is flooded with videos titled How I Would Code If I Could Start Over. However, there are very few videos like these for mechanical engineering, so hopefully my videos will be able to fill this void and provide value to any of you thinking about getting into or currently studying mechanical engineering. So before I talk about the exact sequence of courses I took in university, I think it's important to ask the question, why is having a course planning strategy so critical? The first reason is pretty obvious. Having a plan allows you to meet your school's curriculum requirements and allows you to graduate according to schedule to save both time and money. For example, at my school, we had to satisfy at least 135 credits by taking a mix of core engineering, humanities, and social arts courses. The second reason is many engineering courses have prerequisites, meaning you need to complete certain courses before you can take others. For example, you need to take statics before you can take dynamics, or calculus before you can take differential equations, because these classes use knowledge gained from previous classes to solve problems. The third reason is you'll likely specialize in a specific area of mechanical engineering, such as robotics, aerospace, automotive, or manufacturing. Planning allows you to select electives that align with your interests and career goals. The fourth reason is internships, co-ops, and research opportunities. Course planning helps you to align your academic schedule with these opportunities and makes it easier to secure relevant work experience. Last but not least, just like everything else, having a plan and mapping out your courses helps you manage your time and commitments, whether that's extracurricular activities or partying, so you don't have to worry if you'll graduate on time because you forgot to enroll in a course. Now I'll talk about the specific courses I took and the key concepts you should focus on in each course, starting the fall semester of my freshman year. My school recommended that we take Calculus 1, General Chemistry, Intro to Engineering Computation, and Writing Seminar for a total of 16 credits. I took Calculus 2 in place of Calculus 1 and Physics 1 in place of General Chemistry because I took AP Calculus and Chemistry in high school, which gave me a head start and saved me quite a bit of time and money because most universities assess tuition based on a number of credit hours you take per semester. So take as many AP classes as you can if you're still in high school. If you can get a 4 or 5 on the AP exam, most universities will count these towards your credits. Now, one big mistake I made freshman year was skipping some of my 8 a.m. lectures for Calculus 2 class. I naively thought I could just simply self-learn the material and do a bunch of practice problems and everything would be golden. But it turns out I was totally wrong. There were so many abstract concepts covered in such a short period of time, such as logarithmic functions, sequences, series, and methods of integration. I just couldn't keep up with the huge workload, and many of the concepts were very difficult to understand. Reading the textbook and taking notes simply didn't do the job. I felt like I needed either a tutor or a way more effective learning strategy. I ended up getting a 73% on the first midterm, which was way below the class average of 83%. This also affected my grades in physics and other core engineering courses because they all use concepts from Calculus 2. So after the first midterm, I started to do more practice and discovered a way more effective and smarter way of learning that boosted my grades significantly with Skillshare, the sponsor of today's video. You probably heard of Skillshare by now. They're a fantastic platform offering a huge selection of online courses from programming to CAD to 3D printing, as well as courses on public speaking, crafting a resume, and productivity. Basically has everything you need to succeed as an engineering student. Skillshare also has classes on all sorts of creative career-related topics such as cooking, photography, music, and freelancing. SOLIDWORKS 2021 Learn 3D CAD using real-world examples is one of my favorite courses and taught me all about CAD and product design. It contains 148 lessons covering the process of creating sketches, 3D parts, assemblies, and drawings using various tools and features in SOLIDWORKS while teaching best design engineering practices with 12 real-life objects, including a Coke bottle, Legos, and a PCB board. So if you're a student wanting to maximize your performance in some of your classes or develop some of your soft skills, definitely check out their classes. The best part is you can access all of these courses for free during a 1-month free trial. So if you're one of the first 500 people to use my link in the description below, you'll get access to a completely free 1-month trial of Skillshare. During that time, you can take as many courses as you want, and if you like it, you can continue with the premium subscription of Skillshare. Now, picking up where we left off, the moral of the story is learn Calculus 2 well. It'll pay dividends in all of your later engineering courses. Now, moving on to Physics 1, we learn about Newton's laws of motion, thermodynamics, and fluid mechanics. This class was very challenging because it was so fast-paced and included pre-lectures, homeworks, quizzes, labs, and 3 exams. I remember the first midterm average was a 55%, but luckily the professor was very generous and curved everyone's grades. If I could take this course again, I would spend more time on the pre-lectures to better prepare for the lectures and do more practice problems to develop my problem solving ability more so that I could perform better on exams, which accounted for 65% of our final grade. Unfortunately, I didn't take AP Physics in high school, which I highly recommend doing. Intro to Engineering Computation class taught us the basics of programming and MATLAB, such as functions, conditional statements, and data structures used to solve engineering problems. I dedicated a lot of time towards this class because programming was a completely foreign thing to me, and it took me a while to get the hang of the logic and thinking in a completely new way. Although this was a programming class, there were 3 written exams as well as weekly homeworks, quizzes, and a final project where we created a graphical user interface to read acceleration data from text files measured on a Boeing 727 using iPhones, apply a moving average algorithm to this data, and finally plot the data. I wish someone would have introduced programming to me in high school so I could have at least practiced coding and given myself a head start. Now, our school decided to teach MATLAB, which isn't open source, so I would recommend learning Python instead, which is more practical and used more in industry. Writing seminar class was mandatory, where we just read literature and wrote essays all day. For me, this was a high effort, low reward type of class because of the amount of work required and the fact I already took AP English Literature in high school. Moving on to the spring semester of freshman year, our school recommended that we take Calculus 2, Physics 1, Mechanical Design for Manufacture, an Intro Engineering elective, and Writing Seminar 2 for a total of 16 credits. I took Calculus 3, aka Multivariable Calculus, in place of Calculus 2, and Physics 2 instead of Physics 1. For my engineering elective, I took Tissue Engineering and Drug Delivery. In Calculus 3, we learned differentiation and integration of functions containing more than one variable in 2 or more dimensions. The exams for this class were pretty challenging and required us to visualize complex geometries and ideas in our head, such as a paraboloid inside a cylinder. At the time, I hated this class because the Asian professor had a very thick accent and was terrible at teaching. I really didn't see the value in this class, so I literally winged all of the assignments and skipped reading the textbook. If I could retake this class, I would put in more effort because many of the concepts are used by mechanical engineers to design, analyze, and optimize mechanical parts and systems in the real world. FEA, CFD, and multi-physics simulation software like ANSYS or COMSOL leverage multivariable calculus behind the scenes to help engineers design products that are safe, efficient, and reliable. Moving on, Physics 2 covered electric and magnetic fields, the Maxwell equations, circuits, and optics. This class was easier than Physics 1 because I started to get the hang of things and how to study more effectively. There were a lot of topics covered in this class, so one thing I wish I did differently was focus a bit more on circuits, electromagnetic induction, and optics, which are used in industry to design things like electromagnetic systems containing motors, sensors, and microcontrollers found in robots, phones, cars, aircraft, and a lot of other high-tech products you can think of. Mechanical Design for Manufacture was a 2-credit course that I really enjoyed and provided a preview of mechanics of materials, material science, and product design. There were no exams, but we did have a final project where we designed a winch pulley system for lifting a 500-pound load using off-the-shelf components from McMaster Car. One regret I have from this class is not talking and connecting with the professor as much as I wanted to. He had a lot of industry and teaching experience and would have been a great mentor. It's much harder to approach professors once you're finished with your class, so definitely take full advantage by connecting with professors when you're enrolled in their class. Tissue Engineering and Drug Delivery was also a 2-credit course that provided an overview of biomedical engineering topics, including bio and smart materials, prosthetics, as well as drug delivery. We had to give a presentation on a product of our choice related to tissue engineering, and I chose to do phakic intraocular lenses developed by Abbott, which are plastic or silicone lenses that are permanently implanted into the eye. This class was pretty interesting, but to me, it was just a GPA booster. Finally, Writing Seminar 2 taught us how to write essays and research papers for a wide range of audiences and genres. Moving on to the fall semester of sophomore year, our school recommended that we take multivariable calculus, Physics 2, electric circuits, design and manufacture, and a humanities elective for a total of 18 credits. I took differential equations in place of multivariable calculus and thermodynamics in place of Physics 2. For my humanities elective, I took reading and writing Chinese. I later found out that I overloaded my schedule that semester. Instead of taking thermodynamics, which was a 4-credit course, I should have taken a 2-credit course called CAD and Machine Components that I took in the following semester for a total of 16 credits. Differential equations and circuits were 2 very theoretical courses that required a lot of work and practice, so they took up most of my time. Differential equations taught us ordinary and partial differential equations, Laplace transforms, and mathematical modeling. There were 3 midterms and 1 final exam that accounted for 80% of the final grade. So doing the homeworks and a bunch of practice problems were key to doing well in this class. I ended up getting a B-, but I probably could have gotten an A if I had more time to practice. Before taking this class, I wish someone told me the wide range of applications of differential equations in mechanical engineering. These equations can be used to model physical systems with changing variables like motion, fluid flow, heat transfer, and vibrations, and optimize the design of control systems, thermal systems, and structural components. Now, in thermodynamics class, we learned the 4 laws of thermodynamics, various thermodynamic cycles, and vapor and gas power systems. The math in this class was not difficult at all, but the problems we had to solve had very lengthy solutions over 2 pages long. Again, I wish I would have practiced doing more problems and actually understood the applications of thermodynamics in engineering. Thermodynamic principles are used to design things like internal combustion and jet engines, as well as HVAC systems. I found out that most courses in university don't even tell us why the course is important, so we automatically assume it's useless. But if we actually dig a little deeper and try to understand the applications of a course before we take it, generally we feel more motivated to learn the material because we see the value in it. In electric circuits class, we learned DC and AC circuit analysis, Ohm's and Kirchhoff circuit laws, as well as operational amplifier, capacitor, and inductor circuits. This class consisted of 2 midterms and 1 final that accounted for 70% of the final grade. The toughest part of this class were actually the 6-hour labs where we had to apply the theory we learned in class to build different circuits to accomplish a task using breadboards, resistors, capacitors, op amps, oscilloscopes, multimeters, and function generators. Now these labs were simply a nightmare for me simply because I've never seen or touched a circuit in my life. It wasn't until later I found out about a very fun way for beginners and hobbyists to learn about circuits and programming. I totally wish I knew about this Elego starter kit before taking circuits class. The kit comes with over 1,000 components including a breadboard, control board, wires, sensors, LED lights, diodes, transistors, a shift register, and a servo and stepper motor. And what's even more impressive, it's only $45 on Amazon. Having this kit would have helped me tremendously with retaining more of the concepts from this class and fly through the labs. So if you're interested, check out the link in the description below. Now, design and manufacture class was a 2-credit course that taught us how to work together in a team to design and build a prototype given a budget using CAD and various manufacturing processes using our school's machine shop, such as CNC machining, drilling, and 3D printing. Our team made a desk lamp organizer using materials sourced from McMaster-Carr. One thing I wish I had done more for this class was pick the brains of our machinists and watch how they program the CNC machines with CAM software. Because my schedule was so jam-packed that semester, I took reading and writing Chinese to fulfill my humanities elective requirement. This was an easy A for me because I was already fluent in Chinese, but looking back now, I probably should have taken a course that actually interested me. For the spring semester of my sophomore year, our school recommended that we take differential equations, mechanics 1, which is statics, a social science elective, CAD and machine components, and linear algebra for a total of 16 credits. Because I had already finished all of the math courses, I decided to take material science in place of differential equations. I didn't have to take the required social science elective because I took AP US history in high school, and my university gave me 8 credits, which is equivalent to 2 social science courses. Not having to take these 2 social science electives was so nice and saved me a ton of time. Material science taught structures and properties of metals, ceramics, polymers, and composites, heat treatments, strengthening mechanisms, and phase diagrams. For the most part, this class was pretty straightforward and used less math compared to other engineering courses. That's not to say the workload was small. There were 4 labs about the microstructure characterization of aluminum, X-ray diffraction, diffusion, and phase diagrams, as well as a final project where we examined the effects of TIG welding on the properties of 1075 spring steel. If I could retake this course again, I would focus more on learning the material properties of common engineering materials and understanding heat treatments, strengthening mechanisms, and surface treatments, which are useful for interviews and in industry. Mechanics 1, aka statics, taught us about forces, moments, friction, as well as truss analysis using method of joints and sections. This class was mostly about solving problems and included 2 midterms and 1 final that accounted for 60% of our final grade. There was a final project where we had to design, build, and test a truss made from soda straws and straight pins to maximize the weight it can support. This is a fundamental class that's important for engineers and requires you to do a lot of practice, which I didn't do at the time. Some of the concepts like virtual work are quite abstract. If you're good at trigonometry and geometry, it's likely this class won't be too hard for you. Moving on, CAD and machine components taught us more in-depth computer-aided design using SolidWorks to design parts and create 2D drawings and assemblies. It also covered geometric dimensioning and tolerancing, standard fits, tolerance stack-up analysis, gear train analysis, and standard hardware and machine components like fasteners, bearings, and washers. There was a midterm and a final project where we designed a gearbox assembly from scratch to meet a list of design specifications such as output power. Although I got an A in this class, I definitely wish I bought a book called Machinery's Handbook that I always recommend every mechanical engineering student to purchase. This is like the Bible for mechanical engineering that contains all the concepts you need to know in a single compact book. For any of you who are interested, check out the link in the description below. For the midterm, we're allowed to bring a 1-page cheat sheet, and I just want to take some time here to emphasize the importance of cheat sheets in engineering. Most professors do not allow cheat sheets, but there are some who do. Whatever the case may be, I strongly recommend making a cheat sheet for each of your classes because it helps you focus on what's important. You'll notice that the knowledge just sticks better and the material is deeply ingrained into your memory. To help you guys out, I went back and summarized all my notes from university and created a 1-page cheat sheet for each class that you can use to prepare for interviews and exams. Link in the description below for anyone interested. The last class I took this semester was linear algebra. This was a 2-credit course that felt like a 4-credit course, which taught us vectors, matrices, systems of equations, determinants, and eigenvalues. Our final grade depended entirely on weekly quizzes, a midterm, and a final exam, so I hated this class. Homework was assigned, but it didn't count towards the final grade, so I didn't do any of the assignments and crammed for every exam, which is a terrible strategy, by the way, for math courses. Of course, I wish I did the homework assignments and practiced more just like any other math class, but luckily it didn't affect my GPA too much. The fall semester of my junior year, my school recommended that we take product design, mechanics of materials, fluid mechanics, and material science for a total of 16 credits. Because I already took material science, I took intro to architecture instead to fulfill the humanities elective requirement. I also decided to take fluid mechanics the following semester because I heard mechanics of materials and fluid mechanics were two very challenging courses and I didn't want to take them in the same semester. So instead, I took engineering economy, which was an advanced engineering elective. Our school required that we take 4 advanced engineering electives from a list of courses that we could choose from. Product design was a project-based course that taught practical skills and theory, including finite element analysis, defining problems, Arduino microcontroller basics, sensors and data acquisition, motor sizing and control, and various mechanisms such as rack and pinion. There was a final team project where we had to redesign and improve a strain gauge load cell provided by a manufacturer called Montalvo by creating a proof of concept. Overall, I learned a lot of valuable skills, but looking back now, most of the parts my team and students designed couldn't be entirely manufactured because we were never taught in-depth design for manufacturing principles, just very basic things like rounding sharp corners and what each manufacturing process involved. This is why an internship or co-op is so important because you quickly learn the art and science of designing manufacturable parts. Moving on, mechanics of materials taught us axial and shear loading, stress and strain, torsion of shafts, deflection of beams, and column buckling. There was a huge workload for this class, including quizzes, a midterm, a final exam, and a final project, and 3 labs covering tensile testing, torsion testing, and bending. If I could retake this course, I would focus on mastering deflection and bending stress of different beam configurations, as well as understanding everything about stress-strain curves. Questions related to these topics are almost always asked during mechanical engineering job interview. Now, Intro to Architecture was a course I took to fulfill my second humanities elective requirement and taught us about the history of ancient and medieval art from pyramids to cathedrals. This class sounded easy, but it definitely wasn't in terms of the workload and the level of memorization required. This class taught me that we shouldn't judge a class by its cover and assume it's easy. Every class in university will likely present different challenges, so we should be mentally prepared. The last class is Engineering Economy, where we learn the relationship between time and money, net present value analysis, compound interest, break-even analysis, and depreciation. But the final exam was take-home, so there was no memorization involved. I love professors who understand that engineering isn't about memorizing formulas. Instead, it's about knowing which formula to use and how to use it given a problem. This class turned out to be very useful in my personal life and career when it came to making financial decisions and investing. In the spring semester of junior year, my school's curriculum recommended that we take Mechanics 2, Electromechanical Design, an advanced engineering elective, Instrumentation and Theory of Experiments, and Probability and Statistics for a total of 18 credits. Since I was ahead of schedule in terms of the classes needed to graduate, I only took Mechanics 2, Fluid Mechanics, Probability and Statistics, and Supply Chain Engineering, which was an advanced engineering elective for a total of 14 credits. Mechanics 2, aka Dynamics, covered equations of motion, Lagrangian mechanics, and rigid body dynamics. This class was entirely theoretical, with a lot of calculus and differential equations, including weekly quizzes, a midterm, and a final exam. If I could retake this class, I probably would have chosen a different textbook like this one by Hibbler, instead of this 1996 Fundamentals of Applied Dynamics that the professor opted to use. The textbook was a classic, but the problems at the end of each chapter just weren't that helpful. I learned that both a professor and textbook can really impact your grade, so don't be afraid to explore different textbooks to use as a supplement and research which professors are teaching a course before enrolling. Fluid mechanics class taught hydrostatics, Bernoulli's equations, and Navier-Stokes equations, boundary layers, and lift. This class felt like 2 classes in one because of the huge workload that included weekly quizzes, 2 midterms, 1 exam, and 2 very interesting labs including continuity equation and Bernoulli equation and friction loss in pipes. Fluid mechanics is not an easy course by any means, so you want to enroll in a class taught by a good professor. At my university, there were at least 3 or 4 professors teaching this class, and I happened to pick the worst one. If you want to become an aerospace or even automotive engineer, you want to develop a solid understanding of all the concepts taught in this class. Probability and statistics for mechanical engineers was a 2-credit course that taught Bayes' theorem, probability distributions, confidence intervals, and hypothesis testing. Even though I took AP statistics in high school, I still had to take this course, which was tailored for mechanical engineering students and covered a lot of new material. Overall, this course was pretty straightforward and included homeworks, weekly quizzes, 1 midterm, and 1 final. If you are planning on becoming a manufacturing or process engineer, this class will be pretty important for you. Finally, supply chain engineering was a very interesting course that covered inventory management, network planning, distribution procurement strategies, and value stream mapping. I'm glad I took probability and statistics and this class in the same semester because there were a lot of probability distribution functions involved. If I could retake this course, I would go back and read the textbook instead of just relying on lecture notes to learn the material. Finally, as a senior, our university recommended that we take heat transfer, an advanced engineering elective, and a social science elective for a total of 12 credits. For my advanced engineering elective, I took mechanical vibrations. I had already received credit for my social science elective, so instead I took electromechanical design. Heat transfer taught the 3 modes of heat transfer, including conduction, convection, and radiation, as well as heat exchangers and numerical methods. The workload was large, but nothing I didn't expect. There were labs, homeworks, quizzes, 2 midterms, 1 final, and a design project. For the final project, we had to come up with an ultimate saute pan by selecting materials and defining the pan geometry to optimize the thermal response and uniformity while ensuring it does not exceed 14 pounds. Cost of materials remains under $100, and the pan is manufacturable using standard industrial processes with SolidWorks and COMSOL. Even though I got an A- in this class, I never attempted to talk with the professor, so when I asked him to write me a recommendation letter for grad school, he didn't know who the hell I was and asked me to ask a different professor. So definitely plan ahead and get to know your professors because you never know when you might need their support. Mechanical vibrations class was primarily for grad students and covered harmonic motion, free and forced vibration of different systems, and vibration control. This class consisted of homeworks, quizzes, a midterm, a final exam, and a project. I found this class to be one of the most difficult in terms of making the right assumptions and the advanced mathematics involved for solving problems. But I ended up getting a B+, which I was satisfied with. The final project entailed designing a vehicle suspension system and finding spring and dash pot values that minimize the root mean square vehicle response. Although I still haven't had the chance to use the concepts from this class in industry, I did find them to be very helpful in grad school when I took vehicle control engineering class. This class is particularly important if you want to become an aerospace or automotive engineer. Finally, electromechanical design class was about working together in a team to solve realistic design challenges. Concepts taught include rotary to linear motion conversion, torque, force, and velocity conversion, and brushless AC and DC motors, as well as stepper motors. The class consisted of homeworks and a final design project where we designed a belt-driven automated lab on a chip manufacturing line in SolidWorks. We used morph and pew charts to narrow down our ideas for each process step, size 6 motors used to actuate our manufacturing line, and performed a financial analysis to calculate net present value and payback period. One skill I wish I had developed more in this class was communication and talking with machinists and technicians more at our school to figure out the manufacturability and assembly of the parts I designed. This class was very practical and ended up using a lot of the concepts like motor control and rotary to linear conversion at my first full-time mechanical engineering job. Moving on to the last semester of my senior year, our school recommended that we take mechanical engineering capstone experience, a humanities elective, and an advanced engineering elective for a total of 12 credits. I had to take instrumentation and theory of experiments since I didn't take it junior year. My humanities elective requirement was already fulfilled with my AP class. I took business technology innovation for my advanced engineering elective. Mechanical engineering capstone experience was a culmination of the 4 years of my mechanical engineering journey in university. Together with a team of 5 students, we worked with Montalvo, who makes web tension control products, to redesign their X-series load cells. Montalvo's customers reported non-repeatability issues, which means that the load cell fails to consistently output the same voltage given the same applied load in a controlled environment. We had to first determine the factors causing the non-repeatability and propose a feasible solution that could be easily implemented. This meant designing experiments and leveraging CAD and FEA software, as well as our knowledge from mechanics of materials, material science, circuits, electromechanical design, and heat transfer. Finally, we presented our results to the entire mechanical engineering faculty. If I could retake this course, I would reach out to Montalvo more to better understand the problem, their in-house capabilities, and how they ended up up solving their non-repeatability issues. Instrumentation and theory of experiments class was notorious at our school for the massive workload and lengthy labs. Nevertheless, it taught a lot of important concepts like precision and bias uncertainty, error analysis, measurement methods, and sensitivity. For this class, there were weekly homework sets, 1 midterm, 1 final, a design project, and 4 labs. The first lab focused on taking measurements with oscilloscopes, multimeters, and dashboards. The second lab talked about strain gauges. The third lab covered flow over a sphere using a wind tunnel, and the fourth lab was about temperature measurement and calibration. Instead of using Microsoft Word, we were required to use LaTeX to write our lab reports. LaTeX is a typesetting language that offers very easy control over your document. Our final project was to design and implement a measurement system to measure the temporal response and frequency response of a mechanical second-order oscillator using a linear potentiometer. Based on my teammates' gesture, I'll let you judge how fun this project was. But in all seriousness, despite the challenges, this was one of the most rewarding courses that I took in university and helped me to become a more well-rounded engineer who understood electronics. It's important for mechanical engineers to understand the fundamentals of circuits, sensors, motors, and data acquisition for designing and testing products using a systems level approach. This is especially true if you want to get into mechatronics or automation. Finally, business technology innovation class taught us how to come up with great business ideas, business models, startups, and funding. Now, to summarize, taking AP courses in high school saved me a significant amount of time and money in college. I wish I had spent more time understanding the concepts taught in calculus and differential equations class because almost every engineering class uses them. Before taking any engineering class, I should have attempted to understand the applications first and research the professors teaching the class, which can significantly affect your motivation and final grade. I also wish I had known about Skillshare, which offers many valuable courses for engineering students such as resume writing, CAD, 3D printing, and public speaking. In terms of workload management, I think I did a pretty good job except the fall semester of sophomore year, where I went a bit overboard. Try to research which courses will be the most difficult for you and spread them out over 4 years instead of taking all of them in a single semester. I also learned the hard way that you should get to know your professors starting the first day of class, not when you need a recommendation letter from them. Now, the design courses at my school taught us how to create 3D models and 2D drawings using CAD and the theory behind manufacturing processes. However, it didn't really teach us how to design manufacturable parts using these processes. So I will say my biggest regret in university was not learning more from machinists and technicians at my school and during my internship, because design for manufacturability is one of the top skills that employers look for in mechanical engineers. Finally, I wish I had started coding and purchased a copy of Machinery's Handbook, an Lego kit, and a graphing calculator in high school. Alright guys, that's all I got for you today. As always, thank you so much for watching, and if you enjoyed this video, be sure to check out part 1 of this video here, or what mechanical engineering interviews are like here. And I'll see you in the next one. Peace.